This lesson is an introduction to writing linear functions in standard form. So the first thing we're going to talk about is what is standard form. Standard form is ax plus by equals c. Now, we've seen this form in the last chapter when we were graphing equations, but we didn't really go into detail about what makes standard form what it is. So standard form has three separate criteria that we need to look at. The first one is that the x and y terms are on the same side. And this typically means the left side. We usually put x and y on the left and the constant on the right. Our second criteria is that the coefficient of x is positive. So when I'm talking about the coefficient of x, I'm talking about the a, the number in front of x, which in this case is the capital A. That must be a positive number. And then our third check mark, our third criteria, is that all our numbers are going to be integers. This means no fractions or decimals. Okay, so I will give you fair warning, not every textbook, not every mathematician agrees on the criteria for standard form. However, for consistency's sake, the entire 9th grade algebra team has decided that these are the three criteria that we are going to look for standard form. Okay, so everything I'm going to talk about is in this first box up here, the steps, where it says step 1, 2, and 3. But instead of going through each of these steps, we're going to actually work through some problems that show how these steps are used. So starting with number 1, we're going to have y equals negative 3x plus 4. So the first thing we have to realize is that this is in slope-intercept form, which means to get this into standard form, I need to move this negative 3x term, this term right here, I need to move it over to the left side with the y. To move it across the equals, I'm going to take and add 3x to both sides. So notice I'm kind of keeping it away from my y. That's because these are not like terms. I cannot combine 3x and positive 1y. So this is a positive 1y right here. Remember, it has an understood plus in front. So when I write the left side, I'm going to put 3x plus y equals, now over here, these canceled out, and I'm left with simply 4 on the right side. So 3x plus y on the left, 4 on the right. The x and the y are now on the same side with the constant on the right side. I have x has a positive 3 coefficient, which is good, and there are no fractions or decimals, which means this is in standard form and I have finished the problem. Okay, so let's look at number 2. Number 2 is going to be y equals 2x minus 1. So again, we need to take and move the x term to the left side. And to move it to the left side this time, remember there's an understood plus in front of this 2x, which means we need to take and subtract 2x from both sides, giving us negative 2x, remember this y is positive, so plus y equals, the x's are now gone, so that equals negative 1. Now in this problem, we have an issue. The x and y are good, but the x, right here in front of this x, that is a negative, and we need that to be a positive. Now we can't simply just remove it. We need to instead manipulate the equation. So we are going to take and multiply every single term in this function by a negative 1. So here's what this is going to look like. We're going to have negative 1 times negative 2x plus negative 1 times y equals negative 1 times negative 1. So notice the negative 1 occurs for every single term. And now we're going to simplify. So negative 1 times negative 2x is positive 2x. Negative 1 times positive y is negative y. Negative 1 times negative 1 is positive 1. Now, some people get a little bit out of shape because they think that the y has to be positive too, and that's not the case. The only term that must be positive is the x term. The y can be negative, the constant can be negative. Only x has to be positive, okay? So this is now in standard form because we have no fractions or decimals, and we just cleared up the issue with the negative, okay? So these are considered similar equations. Okay, they're actually equivalent equations because they end up giving the same line. So negative 2x plus y equals negative 1. If you graphed it, that would give the same equation as 2x minus y equals 1. However, 2x minus y equals 1 is the standard form equation. All right, so let's look at number 3. Y equals negative 1/2 x plus 3. So again, our first step is to add the x term to the left side. Add it to the same side as the y. So when we do that, we end up with 1/2 x plus y equals 3. Okay, and our 1/2 x's once again have canceled out. Now this time our issue is that we have a fraction. X is positive, so that's good. But our fraction on our x is an issue. So to eliminate that fraction, if you'll recall back to chapter 3 or so, when we were solving equations, we eliminated fractions by multiplying by the least common denominator. So in this case, the least common denominator is 2. So we're going to take and multiply every single number in the function by 2. So 2 times that y right there, and 2 even times the 3. Don't forget about the constant. Okay, that's a common error. So 2 has to be multiplied by every single term, giving us 2 times 1/2 is 1x, 2 times y is 2y, and 2 times 3 is 6. So now we've eliminated the fractions. This is now in standard form. Because x is positive, no fractions or decimals, x and y are on the same side. Now one thing I do want to draw your attention to at this point is we really want to multiply by the least common denominator. So there are times that you could go bigger. You could multiply this all by 4 and it would eliminate the fractions. However, we really want to know that our coefficients, so like our 1 in front of our x, our 2 in front of our y, and our constant of 6, they really shouldn't have any factors in common. They should be simplified as much as possible. And notice 1, 2, and 6 have no common factors. Okay, so it's not really a hard and fast rule, but it is a common rule that we try to abide by as much as possible. So we want to make sure that we don't multiply by something too big. So always go as small as possible. All right, so I want you to try number 4. So number 4 is going to be y equals negative 7/2 x minus 3. So go ahead and take a moment and pause the video, and when you're ready, turn the video back on to check your answer. All right, here in just a second, I'm going to show the answer. So if you're not ready, go ahead and pause the video again. So our answer is going to be 7x plus 2y equals negative 6. So you should have first added 7/2 x to both sides. Then you would have multiplied every single term by a 2. So if you got this one correct, if you'll give yourself a little smiley face at the bottom, if you got it wrong, if you'll give yourself a little frowny face so that we know we need to talk about this tomorrow, and then go ahead and get the right answer down. Okay, so let's look at number 5. Y equals 4th. Oh, sorry about that, guys. Let's try that again. Y equals 4/3 x minus 1. So the first thing we want to do is subtract 4/3 x from both sides. So negative 4/3 x plus y equals negative 1. Now, one thing you should probably notice is that we have two kind of uh-ohs here. We have a negative and we have a denominator of 3. So that's an issue. We can't have a fraction and a negative. So instead of doing two separate steps, we're going to combine this down into one step. We need to multiply by a negative to get rid of the negative in front of the x. And we need to multiply by a 3, which is the denominator, in order to get rid of the fraction. So that's what we're going to do. We're going to multiply every single term by negative 3. So we're just combining this down into one step. Now you can do it into two steps, that's fine. But we're going to save us some time. Multiply everything by negative 3. So that's going to give us negative 3 times negative 4/3 is 4x minus 3y equals positive 3. So now we've cleared up the negative on the x term. There are no fractions or decimals. X and y are on the left and the constant is on the right. So that is now in standard form. All right, so let's look at number 6. Y minus 2 equals 1/2 times x minus 4. Now, this is not in slope-intercept form. This is in point-slope form. So we need to first solve this down into slope-intercept form so that we can then convert it into standard form. That tends to be the easiest method. So the first thing we want to do is we want to take and distribute this 1/2 times the x, which is 1/2 x, and then 1/2 times negative 4, which is negative 2. Be careful of your negative. We then would want to add this constant on the left side to the constant on the right side, giving us y equals 1/2 x. Okay, so this 2 over here cancels out, but notice that negative 2 plus 2 is 0, and we typically wouldn't write the 0. Now you can, but we don't typically. So I'm not going to write it because I think most of you would probably not write it. So now we need to get this solved for standard form. So that means we're going to have to subtract this 1/2 x to the other side. Now here's where we need to be careful. We have negative 1/2 x plus y equals, well, when we subtract that x, there's nothing left on that side. And that's what we need to put. We need to put that this equals 0. Okay? So now we need to look for our checks. The problem here is that we have a negative on the x and we have a denominator of 2. So we're going to take and multiply every single fraction, or sorry, every single term by negative 2. Even the 0. So this is going to give us x minus 2y equals, now please be careful, negative 2 times 0 is 0. Don't put negative 2 by accident. You're not adding or subtracting here, you're multiplying. So now if we look, x is positive, no fractions or decimals, and x and y are on the same side by themselves. So that is now in standard form. Okay, so I want you guys to try number 7 for me. So number 7 is going to be y plus 3 equals 6 times x minus 1. So go ahead and pause the video, and when you're ready, turn it back on. Alright, hopefully you're ready to see the answer. Now, if you got to this point, negative 6x plus y equals negative 9, you're on the right path. But hopefully you did not stop here. And I have a feeling that maybe a few of you might have. So be very, very careful. Remember, the issue on this problem is that there is a negative in front of the 6x. And that means we need to take and multiply every single term by negative 1. Okay, every single one of these terms. So when we multiply every single one of these terms by negative 1, your true final answer should be 6x minus y equals 9. So if you got this answer correct, you actually went all the way and multiplied by negative 1, give yourself a little smiley face. If you didn't, fix it, and then make sure you remember, you might want to star or highlight that you need to actually remember to multiply by negative 1 on here. That's a very common mistake, and I don't want to see you do that on your test or quiz. Alright, let's look at number 8. Negative 3x minus 4/3 y plus 7 equals 0. Now, this is not in slope-intercept form or standard form, but we can still get it down into the right form. So the first thing we would want to do is we want to get the x and y by themselves. They're already on the same side, but we need to subtract this 7 to get the constant over on the right side, giving us negative 3x minus 4/3 y equals negative 7. Now, x and y are on the same side. Now we need to look for any issues. So x is not positive. That is one of our checks, and it doesn't check off this time. The other issue is that this y has a denominator of 3. So for the most part, our fraction has been falling on our x term, especially if we're in slope-intercept form, but the fraction can fall anywhere. It can fall on the y term or the constant. But bottom line is you cannot have any fractions or decimals whatsoever. So we're going to take and multiply every single term by a negative 3, because we have a negative here and a 3 on the y. So when we do this, we're going to end up with 9x. Be careful of all these negatives here. So this is a positive 4y, because those 3's are going to cancel right here, equals 21. Now again, we can see that the x is positive, there's no decimals or fractions, and the x and y are on the same side. Okay, so last one, number 9. We're going to have 3y equals 1/2 x minus 2/3 plus y. So again, this is not any form we've really worked with, but we're going to start by getting the terms where they need to be. So the first thing I hope you notice is that you have these two y terms. You have a 3y and a positive y. So the first step might be to get those y's together. So I'm going to subtract y to this left side, giving me 2y equals 1/2 x minus 2/3. So now it looks a little more like what we've been used to. So now our next step is to move the 1/2 x to the left side with the y, giving us negative 1/2 x plus 2y equals negative 2/3. Okay, so notice that these x's canceled out. Now, when we're looking for any issues, we now have things in the right order, but we have a negative on the x, and we actually end up with these two fractions. So there's a negative here, but there's a fraction of 2, and there's a fraction of 3. So when we multiply everything in this problem, we're actually going to multiply by the least common denominator, which in this case is going to be 6. Okay, so 2 and 3 give us the LCD of 6. So we're going to take and multiply every single term, every single one, by a negative 6. Now we're going to have to be careful while we're doing this, but it will clear up all the fractions and the negatives. So negative 6 times negative 1/2 is positive 3x. Negative 6 times 2y is negative 12y. And negative 6 times negative 2/3 is actually a positive 4. So we've gotten rid of the negative on the x. There are no decimals or fractions now, and x and y are on the right side. So this is now in standard form. If you have any questions, make sure you write them down so that you can ask me them tomorrow. If you are good, then make sure you write yourself a note saying that you understood everything as well, so that you can kind of communicate that with me tomorrow.